All right, guys, so we're going to do something a little bit different here. I'm going to go ahead and take the answer key and just kind of explain through each of the problems as opposed to writing out everything. Hopefully, it should be a little bit easier this way, a little bit easier for me. And, sometimes writing with this pen gets a little messy. And that way, I can also explain things out loud, and hopefully, that'll help. I'll add some stuff in where I need to. So we start number one, which angles form vertical angles? So, of course, the key here is for you to know what are vertical angles. Vertical angles, of course, when two lines cross, the angles across from each other are vertical. So, first things first, just in this particular picture, there's several sets of vertical angles, but we're only looking at the pair that would be numbered. So we have 2, 5, 3 up here at the top. You have 4 and 1 down here. Those are the ones you want to look at. So across from each other, real simple. You see the answer there, 2 and 3. Just because in this picture, those are the only two that are numbered and across from each other. Okay, so vertical angles cross from each other when two lines intersect. They're also congruent, right? They're the same value. That's an important thing we see. Number two, every teacher at John Jay is female. Provide a counterexample to the previous statement. Again, a counterexample, or as I go through, I'll highlight all the vocabulary here, doesn't have to be written as an if-then. It is literally one example that makes the statement not true, at least not true all the time. So if the statement is every teacher at John Jay is female, your counterexample needs to be one teacher that is not a female. Mr. Rodriguez is not a female as a teacher at John Jay. Could have named any teacher, any of your male teachers at the school, but all you need is one. You don't need an if then anything, nothing like that. 3, the midpoint of AB is M if the coordinates of M are 1 comma 4, and the coordinates of B are 5, 1. What are, of course it should be R, not 8, the coordinates of A? So this is one where I'm going to draw above it real quick. You're not looking for midpoint, but we are going to use midpoint formula. So you have this, you have A, you have B, and I actually drew this at the bottom, but I'll start with this thing first. But you know what B is. You know B is 1, 4. I'm sorry, 5, 1. And M is the midpoint at 1, 4. What you have to figure out is what is A. So there's two ways to do that, and the first way I show you down here is the actual algebra. I didn't really go over this much in the class, but if you put A and B into the midpoint formula, your A is unknown, so that's where you get x1 and y1 here. But what you do know is you know what the midpoint's supposed to give you, 1 comma 4. So it basically sets up equation, and there are two quick little steps here to solve it. So you have x plus 5 over 2 equals 1, y plus 1 over 2 equals 4. First step is to multiply by 2 to both sides. That cancels out the denominator. 1 times 2 is 2. Then you see down here you get x plus 5 equals 2. Subtract 5 from both sides. 2 minus 5, negative 3. So the x coordinate for your answer. Same thing with y, times 2 to both sides. Cancels out the 2. 4 times 2 is 8. You have y plus 1 equals 8. Minus 1 is going to give you 7. And so your point is at negative 3, 7. Now, the way that kind of uses what I showed you a second ago, I drew down here under 6. And what's going on here is kind of a visual way to see it. So you see the same line here. I'll kind of go back over it. You have your line, you have A, you have M, you have B. And it's literally just looking visually at the fact that a midpoint is supposed to be directly in the middle of a line, obviously. So however far it takes you to get to one point, to one endpoint, it should take you the same distance to get to the other. So the idea here is For instance, if I'm at 1, 4 in the midpoint, from 1 to 5, the x I know for b, that's a plus 4. Well, if I go plus 4 in one direction, if I go minus 4 in the opposite, or if I go minus 4, which is the opposite direction, that'll take me to the other endpoint. And so 1 minus 4 gives me the negative 3. Same thing with the y. I'm at 4. To get to 1 for that endpoint, I have to subtract 3. In the opposite direction, that's going to cause me to add 3, and 4 plus 3 is 7, and that's another way to get the negative 3, 7. So just a couple different ways to get to the endpoint. You know, midpoint is a very simple formula, so they try to complicate it a little bit more. 4, are the lines parallel, perpendicular, or oblique? So we have to get slopes, and in order to compare slopes from what you see here with standard form, we need to get them into slope-intercept form, or what you normally refer to as y equals mx plus b. So to do that, you got to take standard form and solve for y, which you see done here. So it's generally 2 steps. First step's get rid of the x, so you see the minus 9x to both sides. Cancels itself out here. 6 minus 9x stays. Remember, don't get a minus 3x there. 6 is a number. 9 has an x with it. You can't combine them. Second step, divide by the number in front of y to everything. Negative 7 divided by negative 7 is positive 1. So you have 1y equals negative 7 plus 9 over 7x. And, you know, if you get a problem and you have fractions, especially here, don't worry. It's generally actually better that you get a fraction when you're dealing with slope because it's easier to look at. Then you got to do the same thing to the second one. Again, step 1, get rid of the x, cancels it out. Do it to the other side. You get 9y equals negative 5 minus 7. Second step, divide by the number in front of y, 9. And you get negative 5 over 9 minus 7 over 9. And so here's the slope for that one. So I'm looking at positive 9 over 7, negative 7 over 9. Parallel slopes would have to be the same thing. Those are clearly 2 different slopes. Perpendicular is what we call opposite reciprocal. If you remember, that means the numbers are flipped and the signs change. So you have a positive and a negative, so that's going on there. And then the first one is 9 over 7. 7 1 flips it, second one to 7 over 9. So that contains both of the things that a perpendicular does. It's perpendicular. And just a reminder, oblique, what it literally means is that the 2 lines intersect, but nothing special about the intersection. Here it's basically like none of the above. Right? They're not parallel, they're not perpendicular. If neither of those would have been true, then you would have gone with oblique. 5, write an equation perpendicular to the line graph below. So to write an equation, you need a point and a slope. You see the 2 things here. I know the problem didn't say it, but usually when we did these before, you use the point they gave you. So we used point P, which was at negative 1, 0. And the slope has to be perpendicular to the line given. Well, AB is at negative 1, 4, because you see at A, you go down 1 over 1, 2, 3, 4. But perpendicular to that would flip it, 4 over 1, and make it positive. So positive 4. Then there's an equation called point-slope form, because you have a point and a slope. And it's y minus y sub 1 equals slope m times x minus x sub 1. And so the point gives you x1, y1, which you see labeled here. And the slope is 4. That's m. So you plug it in, and you start with y minus 0 equals 4 times x minus negative 1. Minus negative becomes plus. The minus 0 doesn't matter. And then you just have to distribute the the positive 4. And in this case, that pretty much does it, and that's where we get the 4x plus 4. So it's literally just plugging into the equation. 6. Write a line that is perpendicular to a segment it contains. A line that is perpendicular to a segment it contains the segment's midpoint. Perpendicular bisector. All right, that's a vocabulary term there. 7. All right, so on this, I'm just going to kind of leave that up there. Supplementary angles in a picture like this are either going to be the linear pairs, the two lines next to each other, two angles, that form a straight line, or either of your same side consecutive interior. That could be something like 4 and 16, or same side exterior. Those would be supplementary. 7, 11. Right, those are consecutive interior. All those would fall under the supplementary category. Congruent, you can go vertical angles, 1 and 6, 3 and 8, 10 and 13, 12 and 15. Obviously, I listed different pairs there. You can also go corresponding, which I guess connects numbers to C, and that's fine. Congruent angles, corresponding angles are congruent. Corresponding is like 1 and 9. In their group of 4, they're in the same position. 11 and 3, 13 and 15. Right? Any of those pairs there that are in the same position. So those all fall under congruent. You can look at what's listed there. 8. In the figure, J is parallel to K. Solve for X and find the value of every angle. So first of all, the two angles that you're dealing with here, 5x minus 2 and 3x plus 4, those are same side exterior angles. And you should know that if it's same side, that is supplementary. So you take 5x minus 20 plus 3x plus 40 equals 180, and you solve that. And you can see the algebra here. You got to combine like terms first. 5 and 3 is 8. Negative 20 and plus 40 is plus 20. You do the algebra, you're going to get x equals 20. You got to plug it back in. First, 5 times 20 is 100. Minus 20 is 80. 3 times 20 is 60. Plus 40 is 100. And then notice that when you do that, you basically fill in the rest, because 80 shows up 4 places, 100 fills in those other 4, and every angle is either 100 or 80. Okay? 9. If two of the angles in a triangle have measure of 58 and 71, what must the supplement of the third angle be? So again, be very careful. Make sure you read questions very specifically. This is asking for the supplement of the third angle. If you understand what you're doing, the third angle supplement and the other two angles in the triangle should be the same thing. So if you're smart about it, just adding those two numbers does give you the supplement, and you're done. Like we talked about, and hopefully you remember, even if you don't remember that, if you know the other stuff, you should be fine. Because what most of you will do will go from there. You still have to add them. You subtract from 180, you get the third angle, and then 180 minus that third angle takes you back to 129. So you get the answer, but a couple extra steps there. Last one on this page, list the angles from smallest to largest. You have to take the longest side, so we'll start with the smallest, I guess. So 3.6 is your smallest side. That's across from the largest angle. So 3.6 for y to x. The angle across from that is z. That's your smallest angle. All right, and then 4.5 is your middle side from z to x. That's across from the angle y. And then the kind of hypotenuse, we don't really know if it's hypotenuse, but the longest side, 5.8, that's going to be across from x. And so you go in that order: small, medium, large. All right, so that's the first page. Hope that helped. There'll be videos for the next two pages as well. And good luck on the semester exam whenever y'all take it this coming week. Adios.